Hello everyone, welcome to AMA1501 Probability Distribution Group Project, and we are Group 5, and we have DAI Yuhang, GUO Qirui, Zirui, Zhaoyu, and Houhe, and our group will give the answers and solutions of question 3. So now, let's start with question 3.1 about expected value, and the presenter is Zirui. So the question A is to calculate the insurance company's expected profit. So we just use premiums per year 1,000 minus the value of diamond 50,000 times the probability that the diamond will be stolen 0.01, and it equals to 500. And question B is to find the premiums that the insurance company should charge if it wants its expected profit to be 1,250. So we can set the premiums as X. So X minus the value of diamond 50,000 times the probability that diamond will be stolen 0.01, and it should equal to 1,250. So the X should equal to 1,750. Okay, so let's continue to the question 3.2, also about expected value, and the presenter is also Zirui. So the question A is to find the expected return and standard deviation for stock X and stock Y. So first of all, let's find the expected return for stock X and stock Y. So according to the form, we can find that the EX equals to 0.2 times 20 minus 0.2 times 50 plus 100 times 0.3 plus 160 times 0.3, and it should equal to 72. And EY should equal to 50 times 0.2 plus 130 times 0.3 plus 200 times 0.3 minus 120 times 0.2, and it should equals to 85. Okay, so the standard deviation for stock X equals to square the expected value of X squared minus the square of EX. So the answer is about 77.95. So the standard deviation for stock Y is the same as stock X, so the answer is about 115. So question B is to find the coefficient of variation for stock X and stock Y. So the coefficient of variation should be the standard deviation divided by variance. So the coefficient of variation for stock X is 77.95 divided by 6,076 times 100%, and it should equal to 1.28%. So the coefficient of variation for stock Y it should equal to 115 divided by 13,225 times 100%, and it should equal to 0.87%.
Hello everyone, my name is DAI Yuhang, and I'm going to cover the questions 3.3, 3.4, and 3.5. For the question 3.3, this question is mainly focused on the binomial distribution. And let's get started with the question A. So let X denote the number of rings that are returned. Then we could find that X follows the binomial distribution. Therefore, the probability of X greater or equals than 2, it's equals to 1 minus probability of X equals to 0, and minus probability of X equals to 1. And we substitute the binomial formula to the X, and we can get 0.1648. So the probability that at least 2 will be returned is 0.1648. Let's turn to the question B. And we could let X denote the numbers of graduates that go to college. And we could find X also follows the binomial distribution, and with its n equals to 20. And also the successful probability is 0.3. Therefore, the probability of x equals to 7 is we can substitute the binomial formula to it, and we can get 0.1150. So the probability that exactly 7 graduates will go to college is 0.1150. Okay, let's go to the question 3.4. And this question mainly focuses on the approximating the binomial distribution use normal distribution. So that x denotes the numbers of the atoms purchased, and it follows a binomial distribution. And we can also, from the questions, we can find that it's n equals to 2000, and also the successful probability is 0.22. And since its NP equals to 440, it's greater than 5, and also NQ is equals to 1056, and also greater than 5. So we can approximate x using a normal distribution. So we can also calculate from the above formulas that its mu equals to 440, and standard deviation equals to 18.52. So x follows a normal distribution with mu equals to 440, and also the standard deviation equals to 18.52. So that A denotes the numbers of stocked atoms exactly leading to the shortage. Then we will have the probability of x greater or equals to A. Here we will use a correction. The probability of x equal or greater than A is equal to the probability of x greater than A minus 0.5. So we will convert this x normal distribution to the standard normal distribution, and we can have its probability equals to the probability of z greater than A minus 439.5 over 18.52, and it's equals to 0.01. And then we can calculate that A equals to the 482.559. Because A denotes the numbers of stock atoms, so A has to be an integer. Then A is 482. Therefore, 482 units of the cell's atom should be the store stock in order to have at most 1% chance of running shortage of the atom on the day of the sale. And then we go to the 3.5 question. And this question mainly focuses on the Poisson distribution. And let's get started with the question A. That x denotes the numbers of inquiries received by a company per hour. And then x follows the Poisson distribution with a lambda equals to 5. And we have the x greater or equal than 5 is also equals to 1 minus the probability of x is 0 minus the probability of x equals to 1, and minus the probability of x equals to 2, and minus the probability x equals to 3 and 4. And we substitute the Poisson formula to those probability functions, and then we have the probability of x greater or equals to 5 is equal to 0.5590. Therefore, the probability that there are at least 5 inquiries within a randomly selected hour is 0.5595. And let's continue with question B. So we let y denote the numbers of hours that have more than 4 inquiries each out of the 18 randomly selected hour. Then y will follow a binomial distribution, and also with n equals to 18, and success probability equals to 0.5595. Since the NP is equals to 44.76, it's greater than 5, and also the NQ is 35. 0.24 is also greater than 5, then we may approximate y using normal distribution. So the mean and standard deviation could be calculated, and we have the y follows the normal distribution with the mu equals to 44.76 and the standard deviation equals to 4.4404. And the probability of y greater or equal than 50 is equals to probability of y greater than 49.5. Here we use a correction, and we turn this normal distribution of y into the standard normal distribution, and we can have its probability equals to the probability of z greater than 1.067, and it's equal to 0.1423. Therefore, the probability that at least 15 out of 18 randomly selected hours have more than 4 inquiries each is 0.1423.
The question 3.6 is about the Poisson distribution, and here is the solution of question A. First, let x denotes the number of patrol cars pass through the neighborhood, so x follows the Poisson distribution with lambda equals to 5. And for the Poisson distribution, the probability of x equals to k equals to e to the power minus lambda multiplies lambda to the power k over factorial k. So here k equals to 2, and the probability of x equals to 2 is 0.08422. For the question B, here is the solution. First, let x denotes the number of messages of the professor receives. So x follows a Poisson distribution with lambda equals to 6. So px greater than or equal to 5 is 1 minus px equals to 0 minus px equals to 1 minus px equals to 2 minus px equals to 3 and minus px equals to 4. And the final result is 0.7149. The question 3 is about normal distribution, and here is the solution of question A. First, we denote x as the price of the stock. The mean is 40 and the standard deviation is 9.1. So the x follows a normal distribution with mu equals to 40 and sigma equals to 9.1. So the probability of x greater than or equal to 50 is pz greater than or equal to 1.1. And here, the z follows a standard normal distribution, so the result is 0.11357. For question B, here is the answer. First, denote x as the score, and mean equals to 500 and standard deviation equals to 50. So x follows a normal distribution with mu equals to 500 and sigma equals to 50. Then we denote the lowest score as x0, so the equation is px greater than x0 equals to 0.06. Similarly, we transform x to the standard normal distribution z and get that x0 minus 500 over 50 equals to 1.55. So in the end, the x0 equals to 516.7.5.
I'm GUO Qirui, and I will talk about question 3.8. We can see that the question A, the mean amount of gasoline and surface charged by this company credit customers is 72 per month, and the standard deviation is 12. So the x is follow the normal distribution, 72 and 12. So according to the normal distribution, the question is to find the probability of the customers charged between 75 and 83. So we can to use the 75 minus 72 and divide it by 12, and use the 83 minus 72 divided by 12. And between these, we can calculate that z is between 0.25 and 0.92. And according to the z table, the probability is 0.4013 minus 0.1788, and the answer is 0.2225. And the question B is about x is follow the normal distribution. The mean is 2 liters, and the standard deviation is 0.012 liters. So the question is about the probability of a container have less than 2 liters. We can find this answer use the 2 minus 2.02 divided by 0.012. So z is less than negative 1.67. And the probability of this is equals to probability that z larger than 1.67. So according to the z table, the answer is 0.0475.
This is the last part of this presentation. The presenter is Liu Houhe, and questions 3.9 and 3.10 is related to normal distribution. Firstly, let's talk about question 3.9. From the question, we can see that if we denote x as daily sales amount, and x is followed for the normal distribution with mean of 33,000 and standard deviation of 8,000. Firstly, we need to find the probability that x is between value of 24,000 and 42,000. Firstly, for the first line, we can get a first equation, and for the second line, we need to normalize this normal distribution to the standard form. And after the normalized, we can find that the z value should located between negative 1.125 and positive 1.125. And due to the symmetric property of the normal distribution, this probability is equal to 1 minus 2 multiplied by the probability that z is larger than 1.125. And from the normal distribution table, we can get that the result is 0.7416. And for the second question, we need to find the amount of daily sale that exceeds 95% of totally daily sales. If we denote this number as A, we can get the first line equation. Normalize this equation, and we can get that if a value has a probability greater than 0.95, which means negative of this value probability is greater than 0.05, which is the third line equation of the solution. Get the value from normal distribution table, we can got A equal to 19840. For the last question, question 3.10, this is also a question related to normal distribution. Firstly, we need to denote the waiting time as x. And the mean of x is 10, and the standard deviation is 3. First question need to ask to find the probability that waiting time is less than 8. After get the first equation, normalize this probability distribution to standard normal distribution. We can get z is less and equal to negative 0.67. Due to the symmetric property of normal distribution, we can get z is greater than positive 0.67. And from the table, we can get the result is 0.2514. For the part B of this question, we need to get the probability that x is greater and equal to 12.5. After you get this equation, same way, normalize this equation to the standard form of normal distribution. We can get z need to be greater than 0.83. From the table, we can get 0.2033. This is the end of this presentation. Thanks for your listening.